In section 1.8, we're generally going to be looking to find one of three things, and that's going to be listed at the top: perimeter, circumference, and area. So again, descriptions of perimeter and area are given. Perimeter is the sum of the lengths of its sides. You're thinking basically the distance around an object. Area is going to be the amount of space it encloses, so that's basically like the area within an object. If you want to pause the video for a second just to get these formulas down from the beginning, this is just pointing out that we do have separate formulas for each type of figure. A square, we have separate formulas for perimeter and area. We have a little bit different formulas if we're looking at a rectangle rather than a square. Triangle is yet another series of two formulas that we're going to be using. And circle, kind of look at their unique shape because this time we're not describing perimeter, rather that distance around, we're using circumference instead. But yeah, two formulas again if I'm finding either the circumference or the area. We also want to be careful of units when we're answering a word problem. So units for perimeter, since I'm just using perimeter to describe a length, I'm just going to use what we call like these linear measurements: inches, feet, yards, miles, centimeters, kilometers, so on and so forth. But if I'm looking for area, and we're going to see the reason why we use these units later on, but I would need to describe those as square units, which you might have seen: square inches, square feet, square yards, square miles, square kilometers, all that kind of good stuff. Again, if I'm describing this as an area region encloses, we're just going to be using what we call square units. If I'm looking to solve a question, though, just looking for one thing in particular, this case is going to be edging material as we read through the question. If I'm using a rectangular garden, I immediately want to think what kind of formulas are going to apply. So a rectangular shape is going to mean either the perimeter or the area formula, depending on what I'm looking for. And in this case, with a question where I'm dealing with specifically what we call that edging material, I want to be thinking perimeter rather than area as I'm looking to start this question. But that means if I am looking for the perimeter around this object, again, thinking of my edging, that's going to be needing two things. We're going to need a measurement for the base length and the height length. You could also think of that as length and width, which you might have used in a perimeter formula. But yeah, again, if that's the formula that I'm given, that perimeter is going to be twice the length of the base plus twice the length of the height. Or again, you could also just group those together as base and height combined. We still need to figure out what those two measurements are for the base and the height lengths in order to substitute it into my equation and find that for the perimeter. Do want to be careful on this sort of question. We're given a few measurements. We're given, for example, like 16 is just this measurement here. But notice if my path is supposed to be 4 feet wide, that means that if I have a path on the left and a path on the right in terms of my base, that's going to be an extra 4 feet on either side. So if I add all that together, it looks like for the base area that we're going to call this is going to be looks like a total distance of 24 rather than 16. For a similar reason, if I'm trying to describe the height of this shape, it looks like 22 is the height of just kind of like that garden in the center. But if I have an extra path on the top and if I have an extra path on the top, I need to add in those like we did for our base. So adding all those together, again 22, but then with 4 on the top and 4 on the bottom, that should give me, I think, 30. And again, that was going to be our height measurement. So if I know that 30 is our height and 24 is our base, last thing left is to substitute those into our expression. So now that I'm substituting, that's going to be, again, 24 that we found as a base measurement and 30 that we found as a height measurement. Those could actually be interchanged and we're going to get the same answer. But all I want to do from this point is work through my order of operations, multiply first before adding. So if I get 48 and 60, that's going to combine to be, I think, 108. And again, if this is an answer looking for edging material and that was perimeter, we need to make sure this is the correct unit. So that would be feet and not something like square feet. Again, we're not looking for area, we're just looking for that perimeter. With circles, again, it's going to be slightly different. So little things about naming in this section, you always want to make sure you pause, get down. We want to make sure we're naming a circle correctly, just with like basically a circle symbol. We name it by its center. So like circle A, if I had a circle with the center A. We're going to be using pi in these formulas, which you guys might have some experience with before, but again, essentially it's the ratio of a circumference of a circle to its diameter. Those always going to be keeping the same ratio, so pi always has that same value, again 3.14, so on and so forth. We can use a pi key in our calculator to get the most accurate answer, but for a lot of these answers too, we're going to find that we're leaving them in terms of pi. So a good explanation of that is this first question where I'm looking for specifically circumference. And again, the top of this page is going to be helpful, or top of the previous page rather, if I go back to find these formula for the circumference of my circle. So let's just keep track of that at the top. It's going to be either equal to pi times what we call the diameter, or 2 pi times what we call the radius. And it really just comes down to the question in terms of what they give you to start. It looks like we're given on this question, 15 inches is a measurement of the circle's diameter. Again, diameter meets with both endpoints on the circle passing through the middle. So if I want to find the circumference of the circle, and again, we would refer to this as circle M if I was trying to name this one, it's just going to be as simple as substituting in that 15 for my diameter and just making sure we're using the right formula. So if diameter is what we're given, pi times diameter is the formula to find that circumference. And it looks like if this is 15 pi would be an answer, again, just in terms of pi. That's what they mean. Just leave that in terms of pi and just tack on an inches at the end because we're looking at a linear measurement, much like with a perimeter. Again, circumference is describing going around my circle, not inside of it. And then also if I wanted that to round that to the nearest tenth, all I'm doing is I'm doing 15 times pi. You might find it as a key on your calculator, but what that comes out to as a decimal, again, nearest tenth is 1 decimal place. That should, I think, come out to 47.1 if you found the right key. So you don't really want to use 3.14. That does kind of round it a bit too far. So if you're able to find a pi key on your calculator or a calculator you're using during class, that's a good thing to use instead of 3.14. 3.14 is all right, but yeah, it's just a little bit more accurate if you use the pi key. Trying that next example, again, good one to try by yourself, but there's only one slight difference on this question, and that's going to be that you start with the radius rather than the diameter as we did on the last one. So this time, if I know that the radius is 4, all I want to make sure is I'm plugging that into my correct formula for the circumference, again, 2 pi times the radius this time instead of pi times diameter. And if I get that as a measurement of both answer in terms of pi, I get 8 pi, again, centimeters, not centimeters squared. Using my pi key on my calculator, I can also find that as a decimal. If I multiply that, 8 times pi just comes out to about 25.1. So a question like this as well, if I'm given the perimeter of I'm trying to find the perimeter of a triangle. If I have a question like this in the coordinate system, it does help to cover our section on the distance formula. You don't really need to use it for any kind of vertical or horizontal measurement. Easier way to find the perimeter, again, if I need to find the perimeter in this shape, I'm going to need to add those 3 sides together. So the length of EF, the length of the bottom side from G to F, and the length of what we'd call, if this is right triangle, the hypotenuse from G to E. If I'm able to find those 3 side measurements and just add those 3 together, there's really no shortcut to find the perimeter of a triangle. I just have to find those 3 sides separate. So if I'm looking for the 3 measurements, again, for the vertical and the horizontal, it's easy enough to just count. If I have a distance of 1, 2, 3, 4, 5, 6, 7, 8 for my my vertical measurement, and it looks like that was the length from E to F, that's going to be one thing I can use in my perimeter formula. So we're just going to keep track of that 8 for now. GF is also horizontal, so that's easy to count. 1, 2, 3, 4, 5, 6. Could also use the distance formula with those points and it would tell you the same answer. But yeah, I might as well use a shortcut if we can and just count either directly up or directly across. For GE though, we can't get away with just using that same kind of a shortcut. This is one where I want to make sure that we're able to use the distance formula between those 2 coordinates and make sure that we can find that length out for ourselves. So if I'm looking for GE, again, we're just going to do some work off to the side. Distance formula is calling back to a previous section, but I'll list it here. It's going to be x1 minus x2, so the difference of your x's, square that, add the difference of your y's, squared. And again, that big square root is like saying if I was to find the 2 sides of a right triangle, I'd want a square root to find the 3rd side. So again, just kind of using the same distance formula we've already seen. Again, it doesn't really matter what you call x1 and what you call x2 as long as you keep those together. So I'm just going to say -3 minus 3. Again, all I'm doing is I'm using the x coordinates from the 2 endpoints of that segment that we're trying to find. And then if I use the y coordinates, again, in either order, I'm just going to use -2 minus 6. We do want to make sure we're using the correct sign, so plus in between and subtraction within the parentheses themselves. When I simplify this out, I get -6 squared for the first term, -8 squared for the second. If you guys got +6, +8, if you guys change the order, it's not going to change your answer, because if I square those, I still get a positive either way. 36 plus 64 makes square root of 100. That all simplifies down after all that work to show that that was just 10 as a length if I was using that same distance formula. So if I have those 3 measurements, 8 and 6 and 10, I can just add those together. My perimeter is simple as, just finding that sum of 24. We're not even really given units here, so I'll just stick to, I guess, 24 for my answer. But let's say if that was like feet as a measurement, that's going to stay feet. It's not going to be something like square feet. Perimeter is always just going to be that linear measurement. I am skipping past problem 4. I left it there if you guys would like to copy that down as a reference. Not one we're going to be asking in class, not one that's going to be on the test. Good to know if you want to work on unit conversion, and if you do want to ask me about that, I'll be more than happy to explain it. But yeah, just to keep this video nice and simple, let's go ahead and skip that one for now. Moving on down to problem 5, this is a case where, again, looks like the last page that we did. This time, though, we have to be careful that we're finding area instead of last time we're looking at circumference. Again, you could refer back to the area formula from the top of your notes, but that should be given as pi r squared. R means the same thing as our last case where I'm using the radius length. We do want to be careful on a question like part A, because what I'm given is not the radius. If I'm given the diameter as a length of 16, to find the radius, it's always going to be half the length of that diameter, because again, a radius is just like splitting that and going halfway across my circle, not all the way across. So we do want to make sure we make that change before I substitute into my area formula, because now that I know that the radius is 8 rather than 16, pi r squared is going to be pi times 8 squared, not pi times 16 squared. This one we're also not even told to write as a decimal. As long as I simplify 8 squared is 64, this is going to be pi, this is just going to be meters, but we do want to make sure, yeah, meters squared now that we're looking at an area. That's all I need to do to find the area of that circle, is just make sure I'm using the correct measurement for the radius. Notice there's really only one input, because pi is always pi. We want to make sure we're able to find the radius correctly and use 16, or sorry, not 16, using 8 rather than 16. Similar question next to it. Again, you're given a circle with diameter 14. Even if we didn't have the circle drawn, yeah, that's still enough to solve it, because we're still doing the same steps as before. Just like how we found before, the radius is half the length of diameter. Need to make sure we do that change first. Need to make sure we're squaring that radius according to the formula. So if we're doing pi times the radius squared, 49 is going to be 7 squared, so that's 49 pi. And again, with my units, I do want to make sure they're square units, not just feet on that question. So area addition postulate is given kind of like segment addition postulate, angle addition postulate that you've seen. It's essentially just a rule that says we're allowed to add stuff up, and that's going to be a sum of our total figures. So when I say that the area of a region is the sum of the areas of its non-overlapping parts, essentially what that means is I could give you a question like this that has kind of like a non-standard shape, like we don't have any kind of one formula for this question, but as long as I'm able to separate this shape into smaller ones that are easier to find, we're just going to add up those individual areas, and that's going to find us the shape of our entire figure. So different ways to break this up, but one thing to consider is, let's say if I just imagine these broken up into rectangles. This first rectangle, I'm already given the length and the width for that, or you can think base times height. So base times height for any rectangle, 9 times 3 is just going to make that 27. We do want to make sure we're using the correct dimensions if we broke up that rectangle in the center. Notice with our congruency markings, that's enough evidence to say that this is going to be a base measurement of 3, just like our base measurement could have been 3 for the first rectangle. Although this time, again, notice we're not using all 9 centimeters for the height. We've removed essentially those 3 centimeters from the top. So if this is 3 by 6 for a rectangle, that's going to be 18 for the area in the middle. And then for that last part, it looks like we actually broke this last part down into a square. Again, using those congruency markings, it's going to be helpful to figure out that, yeah, we can use that as a 3 by 3 square. And if that's a 9 as an area for that last square, again, just side length squared, I can just add those 3 together, 27 and 18 and 9 as my 3 areas. I think that gives me 54. And again, if we're answering for area, we're using those same units, but we're just making sure we're using square units. So again, there's different ways to break this up. I'll just kind of highlight that if you were to choose something else, somebody else could look at this question. They could use rectangles going horizontally. It'd be the same thing. I would have 27, I would have 18, and I have 9 again. We could even break this up into even smaller pieces. Like let's say if I wanted to separate these squares from my figure, that's another way to do it. You could break this up into a bunch of squares, really. It has to be 9, 9, 9, 9, 9, 9. A lot of squares, but it still adds up to be 54. That area addition postulate, again, just allows us to break this up into different shapes, basically whatever shapes are easiest for you to find. With that being said, yeah, with this next question, there's a little bit of a careful decision we want to make about how we break this figure up. Again, good for you guys to try that first before we reveal it, but here we go. There's an important way that we want to break this up, because depending on this kind of a slanted piece, it's important that we make this kind of a separation as a triangle, but again, that could have been a vertical triangle if you guys are considering that question a little bit differently. With that kind of vertical separation drawn instead. But yeah, making that separation allows us to find this as basically a combination of two figures. I found the area of the triangle, again, just finding like this little piece on the top. We found the base and the height by using a similar strategy from before. 12 is the entire length of the base, but if I remove 4 from that, that's going to give us a base for the triangle. And if I'm able to find the base of the triangle, or sorry, the area of the triangle rather, I know that if this area is 16 and if the area of the rectangle is 48, using the same strategy from before, I can then just add those together like the last question and get 64. So yeah, general concept for any shape that we don't have just a standard formula for, some kind of irregular shape, is to break that up into easier pieces, find the area of those individual pieces, combine that, and that's going to be your area of your region.